Hey everybody,
Hey,
it's Amy Bearclaw with the Edelman Planetarium, and with me I've got Ben West, and we are going to try some streaming here from our observatory. We've got a couple of telescopes set up looking at different objects, so let's see what we've got.
so the twinkling of the moons is due to seeing, which is turbulence of the Earth's atmosphere. So that means that basically the light as it's coming to us from those moons isn't going in a straight line. Once it hits the Earth's atmosphere, it kind of bounces around a bit, and sometimes we'll get a bit more of the light, sometimes we'll get a bit less, and quite often the position's also going to move a little bit. So it ultimately makes it so if you're taking a photograph of something, you're going to get a fuzzy image, and if you're looking at it through a telescope, you'll also get a fuzzy image.
So I have a question for you, Ben.
Yes.
So is that why when we look up at the sky at night and the stars are appearing to twinkle, is it
Yes.
because of our atmosphere?
Yes.
Always?
It is.
Okay. Huh.
And you might also notice that the closer it whatever is to the horizon, the worse that is, because you're looking through more air.
Okay.
So the more air's in the way, the worse everything appears.
Okay.
Yeah, so I was going to set that one at Saturn.
Okay, yeah, that works. I can just do that right now. That's a Saturn.
Hey,
yeah, that was Saturn.
You can see it?
That elliptical, you could make out the
You
rings.
can make out the ring, a
Yeah.
little bit of the gap. The issue is that Saturn and Jupiter are getting closer to the horizon. So as I said before, you're going through more atmosphere. It's going to make everything look worse.
Where exactly is the observatory?
What was that, Karen?
Where is the observatory?
Here.
Yeah, it's up on top of Science Hall at Rowan.
Oh, okay.
Yeah. So there is a research telescope. It's a 16-inch diameter telescope, but we're actually just up on the roof. We have a little observing deck where we can set up the smaller telescopes.
Okay, so they're portable telescopes that you brought out with you?
Yeah, the ones that we're
Yeah.
using tonight are just some portables that we brought out. So presumably we'd be able to actually do this from anywhere.
Hey!
It's the moon!
All right, let's get. You guys are gonna love this.
This one is going to be the
If
best yet.
Windows will stop being annoying. Doesn't change the.
Woo. Okay.
Got a moon!
And you can also see the waving of the atmosphere there. That
Yep.
is seeing.
Yeah.
Which is a weird name.
That's awesome.
Yeah,
That looks
that's
amazing.
Isn't that?
awesome. It would look so much better if not for terrible seeing.
Right.
Saturn there.
Exactly what feature of the moon are we looking at, please?
The moon.
Yeah, you're looking at all of the moon right now.
All that's visible.
That's basically the entire visible face of it right now. If you were to
I
go
need
out
to,
and look over in the eastern horizon, it's just starting to rise.
Helpful. I flipped that.
And
Yeah, but okay.
It's
What are
it's actually a mirrored image of what
Yeah,
you
I
should
can
be
actually
looking
fix
at.
it. Horizontal? No, and vertical.
So we're switching it so that it's the way that you would expect it to.
No, that's still wrong.
Yeah.
Undo the horizontal. Okay, so just vertical, which means it's going to be vertical for that too.
But we're approaching third quarter phase.
Yep.
Full moon was on Halloween, so it's a gibbous phase right now. The moon's headed towards third quarter in a couple of days, I think.
Somewhere over here, I think about there-ish, somewhere around there. It's a very big area. Can you see the cursor?
yeah.
Yes.
Okay, somewhere around
Yeah.
there is where Apollo 11 landed. It's also very confusing looking at this because while I just fixed your view, our view is still backwards, which makes it so fun.
Is this one Copernicus
I had no idea.
or Tycho?
I don't know the moon.
Okay. So you can also see. Doesn't like
The
that I'm
moon's
wearing.
too close for me to care. Yeah, if you're wearing a glove, you can
Yeah.
use the
Well,
thing.
yeah, it's fine.
I don't know if you're used to that.
So you can see some really bright craters here and almost dead center right here. These ones in particular are kind of fun to look at because when they impacted, you can actually see that they left these like rays of material. So there's just these little like lines or streamers coming out of it.
So
What it
those are
impacted.
craters from the moon landing?
No.
No.
No, those are
no.
just from.
Oh, from
Basically,
me. Okay, all right.
asteroids
Because you
are-
were talking
Yeah.
about it.
No, you
All right.
can't actually see anything left over from the Apollo astronauts.
Not through a
Okay.
telescope.
Yeah,
on
not
Earth.
through a telescope. Even
Alright.
some of the orbiting observatories that are orbiting the moon
Yeah.
don't have enough resolution that they can really make out details. They
So-
can kind of see some spots where they were.
The Lunar Reconnaissance Orbiter is one of the best orbiters around the moon right now. One of the ones with the best cameras. And with its camera, you can see the landers from the Apollo missions as like a pixel or two wide. So they're like, even with really high resolution cameras placed really close to the moon, these things are, that all the bits from the Apollo moon landings are just tiny. I mean, they're roughly human scale, right? So even with an orbiting spacecraft, it's very hard to make out
Right.
details. That makes it nigh impossible to see anything with a telescope on Earth. By nigh impossible, I mean impossible. What else is bright? Oh, we might be able to see the Andromeda Galaxy like straight up. Want to try?
Yeah, we can try
All right, let's throw
that one.
that one on there so they can still see the funnel moon.
Sure.
Really good connection.
So the dark regions on the moon that you're looking at, those are called Maria. It's actually Latin for seas, because they used to think that those might actually be oceans on the moon. So they're not. They're rock. They're volcanic plains. So what happened was when these big impacts would land on the moon, it would crack the surface and allow for the lava, the molten rock, to sort of spread and fill the lower areas, creating those darker plains. And then you have some meteors that come and land later, and that's what caused the craters that you can see on top. And when they land just the right way, they can create those sprays of material that can create those lines, those ejecta lines that you see against the dark. So while you're looking at the moon, we're moving the other telescope over to another galaxy. We're going to take a look at the Andromeda Galaxy.
Is it warm up there on the roof, Amy?
Not particularly, no. It's about
No?
50 degrees.
Uh,
We're not cold, though, because we've bundled up.
yeah.
Oh, okay, I'm not cold.
I'm cold.
You're saying speak for yourself.
What's your favorite?
His favorite is M82, which is
32.
32, yes, sorry.
Don't let
Which
the
is,
kids go.
It is a galaxy. We're actually looking at, trying to look at the galaxy M31, which is the Andromeda Galaxy, and M32 is a
Let's get it switched over.
satellite, or is it a companion? Are they
Okay,
orbiting each
so
other?
I mean, technically everything's orbiting everything else.
Don't.
The sun orbits the Earth.
Yeah, right.
God, I sound like Eddie. So it's a galaxy that orbits around the other galaxy.
Well, so I still think that
That's
might be.
definitely Andromeda, but I don't have a live view to look at, and I'm afraid to put it into that because all the stars are dim.
So in the middle of the screen is the.
We.
Oh,
You got a
wait a
smear?
minute. That's different.
Yeah, so
Yeah.
you're now.
So that big fuzzy thing over to the side is the Andromeda Galaxy, and I'm
Yeah.
very much eyeballing it.
This is the Andromeda. We're trying to get it centered. And then this now is the satellite galaxy M32.
So M31, or Messier Object 31, the 31st object in the Messier catalog of stuff. And then M32 is the 32nd.
Nerd.
Yeah, I can go further here. The Messier
Please
catalog.
don't.
The Messier catalog was made by a French astronomer named Charles Messier in the I think mid 1800s. He was a comet hunter. He was looking for comets. Comets look like fuzzy things in the sky. Nebulae and galaxies look like fuzzy things in the sky. Nebulae and galaxies don't move in the sky. Comets do. So he cataloged things that didn't move to ignore. But they're bright. So astronomers, amateur astronomers, were like, "Wait, these are fun. Let's look at them." Spiel is over. Is this going to download the new image? Is that the new image?
I think so. I think you moved just a little
Did
bit.
it just not move at all?
It moved a little.
So now we've made it all the way to the edge of the universe and there's nothing more to see.
According to Ben, maybe. Mostly just because he's
restaurant at the end of the universe.
mostly he's just getting frustrated because he can't get it centered. Since we have the way that we've got this set up is rather than eyepieces on the back of the telescope, we have cameras connected to the back. And the cameras are then connected to the laptop, and that's what we're showing you. But it means that when we're changing objects, we can't look.
Is it taking photos?
You're trying to steer it with your
We're trying to
touchpad.
steer it through the laptop rather than through the telescope itself. That's looking better.
Oh.
Yeah, so setting things, trying to center them, trying to get them in focus is a little bit tricky because we can't look at the telescope. We can't see exactly what it's doing. We have to...
There's a camera in the way.
Yeah, there's a camera in the way, so we have to take the image through the software just to see what we're looking at and then try to adjust from there.
And on top of all that, it's a very dim thing, so even if we're looking through the viewfinder on the camera, it's almost impossible to see. Oh! Whoa!
What's wrong?
That's better.
Great.
Oh, so there's M31 and there's M32.
Okay.
So explain again about the satellite galaxy.
So this is a galaxy that goes around that one. In a
Okay.
big ol' orbit. It's very hard
So
to make
how-
out anything there. I apologize. Our sky conditions are awful here. But in a very dark location, you'd be able to vaguely see that this is a spiral galaxy. So it's got a spiral shape much like our own galaxy does. The Andromeda Galaxy is the largest member of the local group, our local collection of galaxies, and it's about twice as large as the Milky Way. So a particle of light would take about 200,000 years to get from one side of this galaxy to the other. And it's actually about, I think, 5 or 6 times the size of the moon in the sky, or maybe it's 3. It's either.
It's a big difference.
Yeah, I think it's 5 or 6. 5 or 6 times the size of the moon in the sky. It's pretty big in the sky, so we're not actually seeing all of it. We're seeing the nucleus or the center of that galaxy. So the Andromeda Galaxy is the largest member of our local group or our local collection of galaxies. And the Milky Way is the second largest member. It would take a particle of light about 100,000 years to get from one side of our galaxy to the other, and it would take about twice as long for the Andromeda Galaxy. So it's a really, really big thing. If you were in an incredibly dark area and you could see the Andromeda Galaxy as brightly as you could see the full moon, it would appear... There was a lovely train. The Andromeda Galaxy would appear to be about 5 or 6 times the size of the full moon in the sky. So it is the most distant object you can actually see with the naked eye alone, and it is bigger in the sky than the closest object you can see with the naked eye, the moon. Well, closest outside of the Earth.
And how far away is?
Oh, it's about 2.5 million. No, 2.5 million.
I always get
4.5 million. 4.5 million light years away. No, it is. It's 2.5 million. It's going to collide with us in 4 billion years. I mixed up the-
no!
No, it's not oh no. It's not oh no. It's not oh no. It sounds
It's
horrible.
beyond
Galaxies
my
are
time.
gigantic. When 2
I
galaxies
had a
collide
car
with stars.
inspection due that day.
So galaxies are huge, and stars are big, but they're tiny. They're minuscule relative to the size of galaxies. So when 2 galaxies collide, all of their stars slip right past each other. And so when we collide, we'll just merge with the Andromeda Galaxy to make the Milk-Omeda Galaxy. Far bigger galaxy. We can try Mars again. It's a
Sure.
bit higher, so the seeing would be a bit better.
Maybe we can try.
Let's try it.
So we're just going to try to point back to Mars one last time. This is going to be the last thing that we're going to try.
We'll release you guys.
Yeah, and then we'll release you.
Let's go ahead and move that one. This one's pointed at Andromeda. Oh no. Oh
Where'd
boy.
you go, Tiny Mars?
There's a Mars. It looks terrible.
That doesn't even look in focus.
No, it's in focus. It's just shaky. So you can make
So
out.
I have questions about the Andromeda
Sure.
Go for it.
galaxy.
Let's see if I can drop it.
How far away is the satellite galaxy?
No
from
idea.
Oh, you have no idea. Oh.
Sorry, I'm not helpful there.
And also, you may not even know this. I don't know if any other galaxies have collided that we know of, but would they just kind of pass through each other and keep going, or would they?
That's essentially what happens. But
This
there
screen's
are
so bright.
there are lots of galaxies that we see mid-collision,
Okay.
Not image.
and we can't see them, through our telescopes. But like the Hubble Space Telescope has seen lots of these galaxies mid-collision, and what we're going to try to do is find
I'm just gonna do a video.
of what it looks like. Yeah, I knew Hubble Site had it.
So the gravitational pull of something in one galaxy doesn't pull
Yeah,
on something in another
right.
galaxy?
So depending on the size of the galaxies, one might be pulling on the other more, and will kind of swallow it up. If they're both about the same size, they'll be pulling on each other equally. But it kind of
That looks awful.
that doesn't look terrible.
That looks
You
awful.
can kind of see some albedo features though.
Yeah. That's,
But depending on the angles that they're coming into each other and the sizes and everything will sort of determine what the end shape is. So astronomers have tried modeling what galaxy collisions look like, since it happens on such a long time scale, even though we can see images, or we take these photographs where we can kind of see that
that's not good.
their collision, we're not watching it on a time scale where we can really see what it looks like. So they've tried modeling it to get an idea of what these simulations look like. So we're going to try to switch over.
I crashed it.
What did you crash? APT?
I'll click back on Orion. So I don't know if anybody can see that.
Is that Andromeda?
No,
you're
that
looking at?
is the
What are we
Orion
looking at?
Nebula.
Looking through a whole lot of...
You're looking. It's really an awful view of it, because you're looking through our field lights. Some steam from the what is it? The heating systems here.
Yeah, it's
just
Everything bad that right. Yeah. Everything that could get in the way of your viewing of astronomical objects is pretty much happening in this image right now, but we still caught it. So this stuff that you're seeing here, this sort of gassy stuff, this is actually where it's gas and dust that is slowly collapsing down, forming new stars. So that's what these bright ones that you're seeing, the bright stars, these are all very young, very hot stars that formed out of that nebula, that cloud of gas and dust. And it's a beautiful object to look at when it's high up in the sky and not being washed out by the light pollution and things like that.
It's not exactly where it is right now.
Right. And it's something that from a decently dark location, you can actually see with your unaided eye. So this is one of my favorites to look at. It's this Starbirth region. Hey, did you see the bolide? There was a meteor, a bright one.
But you, with your naked eye, you can't really you don't.
You
what
can
do you
actually
see,
see
really?
it. And it's basically if you're imagining Orion, which is 7 stars roughly in the shape of a person, you have 3 stars in a straight line that make his belt, 2
Right.
above that for his shoulders, and 2 for his knees.
Right.
Below the belt and offset a little bit is the Orion Nebula, and it's usually drawn as his sword.
Well, I guess we'll call it a night and leave
Yeah.
you to have fun with it.
All right.
Good
It was
night.
fun
Good
being a
night.
guinea pig.
Thank you.
Bye.
Stay warm.
Thanks. Bye.